Okay, this is lesson 7.1, and this is the amount of an annuity. Um, in this lesson, we're going to break it into two parts. The first part's going to be about the future value of an annuity, so how much an annuity investment is worth in the future. And then in the second part, we're going to look at the present value. So first, what is an annuity? Well, an annuity is a series of equal payments paid into our out of into or out of an account at regular intervals. An ordinary simple annuity, the type we're going to look at, are payments made at the end of each compounding period. I'm going to explain what some of these words mean in a second. The amount of an annuity, or the future value, is the sum of all the regular deposits plus the interest you earn. Before we do that, I want to discuss a couple words. Compound period. That's how often we get our interest. Interest is the extra amount of money the bank gives you for storing money there, or it's the extra amount that you owe for borrowing money. If we're compounding annually, that means we're compounding one time per year. Monthly is 12 times per year, and weekly is 52. And now, if we use these three as our basis for figuring out these ones, it kind of makes a little bit more sense. Annually is one time. Semi-annually just means that it's in the middle and at the end, so that's 2 times per year. Semi-monthly means in the middle and the end of every month, so that's 24. And bi-weekly means every other week. If it was semi-weekly, that would be at the beginning and end of every week. Beginning and end, that wouldn't make any sense. The middle and end of every week, it would double it. Bi-weekly means every other, so it's 26. Easiest way to remember bi-weekly is if you work, that's when you get your paycheck every 2 weeks, generally. Sometimes you get them weekly, sometimes monthly, but usually bi-weekly. So you'll get 26 paychecks in a year. All right, so let's look at an example of an annuity. Suppose $450 were deposited at the end of every quarter, that's every 3 months, for a year and a half, into an annuity that earns 10% per year compounded quarterly. So it means every quarter you're getting an extra 10%. Sorry, every year you're getting an extra 10%. Since it's compounded quarterly, you're getting a quarter of that 10% every quarter, which is a little confusing. When we use the big equation, which is a shortcut to filling in this table, I'll show you how to work out that interest rate. But for now, let's just complete the table, and I'll show you how an annuity works. So in our first quarter, at the beginning of the quarter, we don't have any money. So we don't earn any interest. But at the end of the quarter, we put our first deposit in, $450. So we end the quarter with $450 in our bank account. Now at the start of our next quarter, we have $450. So we're going to earn some interest. How much interest? Well, 2.5% of $450. So that's 450 times 2.5% as a decimal, which is 0.025. And we get $11.25. So now our account has 450 plus 11.25 plus, since it's a regular deposit, an annuity, we keep putting money in, we're putting in another 450. So 450 and 450 is 900 plus 11.25 gives us $911.25. Here's where annuities get fun. Now we have $911.25 in our account, so we earn interest on that amount, which 911.25 times 0.025 is $22.78, we'll round down. Much more interest than we earned the first time. In fact, more than double. Why is it more than double? Well, $11.25 is how much interest we would earn on $450. Since now we have $911.25, we're earning the $11.25 on this $450, on this $450, which would be $22.50. There's still a little bit extra in there, an extra 28 cents. Where's that come from? That comes from the interest on the interest that we earned the month before, the quarter before, sorry. which is awesome because now not only are you earning interest on the money you're putting in to your annuity, you're also earning interest on the interest you earned from before. Interest on interest is called compounded interest, which means you're earning money on money that you didn't even put in the bank, which is very exciting. That's how you make a lot of money. So, got lost in the numbers there for a second. We started the quarter with $911.25. We earned $22.78 in interest, and we made another deposit of $450. If we add all those up, our closing balance is now $13.84.03. So let's see if we can finish this table. We're starting the fourth quarter with $1,384.03. If we want to know how much interest we earn, 1384.03 times 0.025. We earn $34.60. And we're going to deposit another $450. And if we add all those numbers up across the column, we get $1868.63. So now what happens? Well, let's look at our fifth quarter. Now we have $1868.63, and we're going to earn interest on that. $1868.63 times 0.025 is $46.71. Let's round it up to 72 cents. $46.72. Put in another $450. Add all those up. Now our account has $2,365.35. Almost done. Last quarter. We start the quarter with $2,365.35. Let's see how much interest we earn. 2365.35 times 0.01225, sorry, not 12. And we get $59.13. Add another $450. We end up with $2,874.48. And that is our final ending balance. And what's neat is you can see where this ending balance came from. We deposited $450 6 times. Well, if we add that up, that's $2,700. So of the $2,874.48, $2,700 of it came from our deposits. The extra amount, which is all the interest added up, $174.48, came from the bank for investing the money. That's the total interest. And there we have it. Total interest plus the total of our deposits gives you your ending balance. So by making these $450 deposits every 3 months, in a year and a half, not only do we end up with all the money we put in the bank, we end up with the interest too, for a little bit more money than we should have. Now, making this table is a lot of work, and we don't want to have a scenario like this and have to build 6 columns to get to a final amount. We don't want to have to make a table. We want to be able to go from the information to this final amount in one calculation. We don't want to have to be able to make the table. Because imagine we change the scenario. Imagine we were putting $450 in every week. No, that's ridiculous. Let's say $45. But we're putting $45 in the bank every week for 10 years. Well, there's 52 weeks in a year. Times 10 years, that'd be 520 columns in a table. Rows, sorry. 520 rows in the table. No one's making that table. It'd be ridiculous. So we need an equation. Let's flip it over. Fortunately, we have an equation. And here it is. A equals R, and we're missing a big square bracket here. 1 plus I to the exponent n minus 1, big square bracket, all divided by I. Now, in order to use the equation, we need to know what all the letters mean. Well, A means future amount. And in a second, we're going to flip back a page. And I'm going to show you where all these are in the table. R is regular payment. I is interest rate. Per compound period. And N is number of compound periods. So the first two are easy to show you where they are, A and R. A is the final amount. This is what the whole equation is built around. We're looking for the final amount. R is the regular deposit. Well, R is this 450. We're putting 450 in regularly. I was the interest rate per compounding period. This 2.5% is I. I'm going to show you how to get it. And N said number of compound periods. That's just how many rows, how many rows we have in our table. Well, that's 6. So let's do a refresher here. N was 6, I 2.5, R 450, A $2,874.48. Let's keep those numbers in mind because we're going to use the equation now to verify this answer. All right, so the trickiest part about using this equation is figuring out what I and N are. A is what we're solving for, and the regular payment's always really clear because it'll say we're depositing this much money every so often. So R is pretty easy to figure out. I and N are tricky. So for I and N, we look for the number with the percent. It was 10%. And it said quarterly. Well, quarterly means 4 times per year. So we take our 10% and we divide it by 4. That's how we get the 2.5%. This is the 10% as a decimal. We always work in decimals for I. N, the number of compounding periods, is generally pretty easy to get to. We start with how many years, and we multiply by 4 because it's quarterly. 1.5 times 4 is 6. And these will be the steps that we're constantly doing. And for the rest of the unit, we're going to be looking for I and N. So if it didn't make sense right now, we're doing about 4 more examples of it throughout the next couple lessons. So you'll get to see where I and N come from more often. But for now, we've got an I, an interest rate per compounding period of 0.025, and an N of 6. So let's write all the letters out. A, R, I, and N are our letters. R was the 450, that was the regular payment. I is the 2.5% as a decimal. And N is 6. So let's use the equation. A equals R, square bracket, round bracket, 1 plus I to the exponent n minus 1, close bracket, all divided by I. Now, let's fill in our numbers. R is 450. 1 plus 0.025, n, the exponent 6, minus 1, square bracket, divided by 0.025. Now, it is easiest if you can practice typing this whole thing in your calculator at once. It makes the math so much easier. If you can't, try to do the entire top first and then just divide at the end. I'm going to type the whole thing in my calculator just to show you that it works. I don't want to cover the math here. There. All right, so we got 450 bracket 1 plus 0.025 close bracket exponent button 6 minus 1 close bracket, all divided by 0.025. So I've just typed the equation in exactly as it's written on the page, and I hit equals. And it gives me $2,874.48, which is exactly what we got from the table. So instead of making a massive table every time we want to do future value of an annuity, we can just use our future value equation. So this equation is pretty important. You'll need that to be able to do any future value question. There's also a little mini equation that'll show you how much interest you earned. And it's right here. Interest, I, is equal to A minus R times N. So what's this mean? Well, I'm going to show you. The total interest the annuity earned is A, which we just figured out, $2,874.48, minus R is 450 times N is 6. So basically we're taking our final amount and we're subtracting away all those payments that we made of 450. And if we do that, we end up with $174.48. And that is our total interest. If we flip back to the table, that total interest is this number right here, I. And that RN part, R, our deposits, times 6 is just this number right here. Taking this number, subtracting this number, gave us that number. So this is how all of the values in the table are related. And we just did our first annuity question. We just determined the future value of an annuity. So if you're making regular deposits into a bank and you want to know how much money you'll have in the future, that's called the future value of an annuity, and it's a future value annuity question, and we'll do it just like we did in this formula right here. In part 2 of the lesson, we're going to look at something called present value of an annuity, and make sure you watch that. It's a part of today's lesson as well.